Good afternoon, everybody. My name is Gaurav Chaudhary. I am Assistant Professor in IT Department at Ajay Kumar Garg Engineering College, Ghaziabad. The topic for this lecture is Big Data Architecture. Now, before we go on to see what is Big Data Architecture, we will talk about the definition of Big Data Architecture. So, Big Data Architecture is an intricate system designed to handle the ingestion, processing and analysis of data that is too large or complex for traditional database management systems. Although there are several big data architecture tools on the market, you still have to design the system yourself to suit your business unique needs. So, in order to do so, you need a data architect to design a big data solution that caters to your unique business ecosystem. So, you will have to customize your big data architecture and select and design the components of the system yourself according to your business needs. And you will need help from data architect, big data architect, who will help you in selecting the components and the design according to your business ecosystem. So, most big data architectures include some of the following components. What are the components? The components are data sources, number 1, number 2, data storage, number 3, batch processing, number 4, real-time message ingestion, number 5, stream processing, number 6, analytical data store, number 7, analysis and reporting, and finally the orchestration. So, a total of 8 components are required to design a big data architecture which will cater to your unique business ecosystem. Now, we will see one by one in detail about these components which form the big data architecture. So, this is the block diagram of a big data architecture. You can see the flow of data, flow of information among the various components in this big data architecture. Starting with, we have got the data sources which is fed into data storage and the real-time message ingestion component. Now, there is a bidirectional flow of data between data storage and real-time message ingestion. The data further flows from data storage to the batch processing component and from the real-time message ingestion to the stream processing component. So, the machine learning methods, techniques are applied to the data which is present in the batch processing component as well as to the data which is present in the stream processing component. After the processing and further enhancement of structurization of data is done using the machine learning techniques, the data is further moved up to the analytical data store and also directly to the analytics and reporting component. business intelligence and visualization. And for all these components to work in tandem, we have got the orchestration component, which is the overall manager for these components. The source of this big data architecture block diagram is docs.microsoft.com. So coming to data sources. So all big data solutions start with one or more data sources, and the examples include your application data stores such as relational databases, or the examples can be your static files which are produced by applications such as web server log files, or the data can be your real-time data sources which you get from the IoT devices, Internet of Things. So these are the various big data sources which will make up your big data solutions. Now coming to data storage component. So we are storing it in batch processing as well as stream processing. So data for batch processing operations is typically stored in a distributed file store that can hold high volumes of large files in various formats. This kind of store is often called a data lake. So options for implementing this storage include Azure Data Lake Store or blob containers in Azure Storage. So the store format is of a data lake, and the options for implementing this format can be found in the Azure Data Analytics component. Coming to the batch processing component. Because the data sets are so large, often a big data solution must process data files using long-running batch jobs to filter, aggregate, and otherwise prepare the data for analysis. Usually these jobs involve reading source files, processing them, and writing the output to new files. Options include running USQL jobs in Azure Data Lake Analytics using Hive, Pig, or custom map reduce jobs in a SD inside Hadoop cluster. Or we can also use Java, Scala, or Python programs in an SD inside Spark cluster. So we are using these techniques of Hadoop cluster or a Spark cluster because our data sets are very large. And to get a big data solution with respect to a very huge data set, we have to use these approaches. Now coming to the real-time message ingestion component. If the solution includes real-time sources, the architecture must include a way to capture and store real-time messages for stream processing. So this might be a simple data store where incoming messages are dropped into a folder for processing. However, many solutions need a message ingestion store to act as a buffer for messages and to support scale-out processing, reliable delivery, and other messaging queuing semantics. So this portion of streaming architecture is often referred to as stream buffering. So options include Azure Event Hubs, Azure IoT Hubs, and Kafka. So this is the way, these are the tools, these are the techniques through which we will be able to ingest the message in real time. So remember, this is not about data ingestion, this is about message ingestion. Now coming to the component of stream processing. After capturing real-time messages, the solution must process them by filtering, aggregating, and otherwise preparing the data for analysis. The processed stream data is then written to the output sink. So if we take this example of Azure Stream Analytics, which provides a managed stream processing service based on perpetually running SQL queries that operate on unbounded streams. You can also use open source Apache Stream technologies like Storm and Spark streaming in an HD Insight cluster. So again we see, because this architecture block diagram is provided by Microsoft documents. So we are seeing the example of Azure data analytics for each and every component. Now coming to the component of analytical data store. So this is a store where finally, after applying your machine learning techniques and doing the processing on the data, your data will be stored. So many big data solutions prepare data for analysis and then serve the processed data in a structured format that can be queried using analytical tools. So number one, the analytical data store used to serve these queries can be a Kimball style relational data warehouse as seen in most traditional business intelligence solutions, or alternatively, the data could be presented through a low latency NoSQL technologies such as HBase or an interactive Hive database that provides a metadata abstraction over data files in the distributed data store. We also have Azure Synapse Analytics, which provides a managed service for large-scale cloud-based data warehousing. HD Insight supports your interactive Hive HBase and Spark SQL, which can also be used to serve data for analysis. Now coming to the part of analysis and reporting. So this is an important component because the goal of the most big data solutions is to provide insights into the data through analysis and reporting. To empower users to analyze the data, the architecture may include a data modeling layer, such as a multi-dimensional OLAP cube or tabular data model in Azure Analysis Services. It might also support self-service BI using the modeling and visualization technologies in Microsoft Power BI or Microsoft Excel. Analysis and reporting can also take the form of interactive data exploration by data scientists or data analysis. For these scenarios, many Azure services support analytical notebooks such as Jupyter, enabling these users to leverage their existing skills with Python or R. So again, for large scale data exploration, you can use Microsoft R Server, either standalone or with Spark. So reporting and analysis. The difference is, a reporting environment is also called as the business intelligence environment, because in such an environment, the users go to select the reports they want to run and they get the reports executed and view the results. The reports may contain tables, graphs and charts in any combination. The key factors that define a report include: the report will provide back to the user the data that the user has asked. So it just provides the data back to the user that the user asks. The data will be provided in a standardized predefined format. There is no person involved in generating a report outside of the user who requested a report through his or her reporting interface. As a result, reports are fairly inflexible. They are not flexible because they just report what you ask. Whereas in analysis, the key points are the analysis provides answers to the questions being asked. So it provides answers, insights to the questions being asked. So an analysis process takes any steps needed to get the answers to those questions. And analysis is therefore customized to the specific questions being addressed. And analysis involves a person who guides the process. Here we have a person who will guide the whole process. So because the analysis provides answers to the questions asked, instead of just presenting the data which is being asked by the user, it provides answers to the questions being asked. So it is very flexible in nature. So summarizing the difference between reporting and analysis, reporting provides data whereas analysis provides answers. Reporting provides what is asked for whereas analysis provides what is needed. Reporting is typically standardized where analysis is typically customized. Reporting does not involve a person whereas analysis we have seen it involves a person which guides the whole process. And reporting is fairly inflexible whereas analysis is extremely flexible. Coming to the last component, which is the orchestration. So in this, the most big data solutions consist of repeated data processing operations which are encapsulated in workflows that transform the source data, move data between multiple sources and sinks. We have seen the multiple sources and sinks of the various components of the big data architecture, and load the processed data into analytical data store or push the results straight to a report or dashboard for reporting and analysis. To automate these workflows, you can use an orchestration technology such as Azure Data Factory or Apache Uzi and Scoop. So this completes the detailed description of all the components of big data architecture. Thank you.